Hi guys, in this video I want to talk about the Lyman and Balmer series. We have talked about the atomic emission spectrum of hydrogen, where it shows a series of lines, and the series of lines seen in the atomic line spectrum of hydrogen would represent transitions of electrons from higher energy levels to lower energy levels. That is, from levels of a higher quantum number to levels of a lower quantum number. From this emission spectra, we are able to draw this energy level diagram. And the energy level diagram shows electronic transitions, right, within the hydrogen atom. So what we are seeing on the screen is electron transitions from higher energy levels to a lower energy level. So an electron absorbs energy, it's promoted to higher energy levels, right? So 2, 3, 4, 5, 6, whatever. In our diagram, what we can see is electrons dropping back down from higher energy levels to the n is equal to 1 level, 2, 3, 4, etc. What we will be looking at are the Lyman series and the Balmer series. Both show electronic transitions from higher energy levels, where in the Lyman series the electron drops back down to the n is equal to 1 level, and in the Balmer series electron drops back down from higher energy levels to the n is equal to 2 level. Now the electronic transitions seen from Lyman and Balmer will correspond to specific frequencies, right? That's the quantum of energy, which is the energy difference between the energy levels, is based on the wavelength of electromagnetic radiation emitted, and this wavelength, if we look to our electromagnetic spectrum, we can determine where it is. In the Lyman series, the series of wavelengths correspond to a range within the electromagnetic spectrum. This range is called the ultraviolet region. And for the Balmer series, this corresponds to the visible region. Once again, to summarize, in looking at the emission spectrum of hydrogen, a series of spectral lines are seen where the spectral lines correspond to specific wavelengths. The wavelengths can be input into Planck's equation to work out the quantum of energy for each electron transition. These different quantum of energy are used to work out the energy levels within an atom, 1, 2, 3, 4, etc. If we look at the series of lines in the hydrogen spectra, where we look at electronic transitions from higher energy levels back down to the n is equal to 1 level, which occurs within the ultraviolet region, or the wavelengths correspond to the ultraviolet region. This is what we call the Lyman series. if we look at the electron transitions from higher energy levels back down to the n is equal to 2 level in the spectrum, the wavelengths of these electron transitions can be found in the visible region of the electromagnetic spectrum. You should be able to discuss both the Lyman and the Balmer series in terms of the energy level diagram seen on the screen. That is, interpreting what it means with regards to the lines or the electron transitions, as well as identify the regions that the wavelengths of these lines correspond to.